So just a little bit of a wrap up then on Mercury. And again, this is a little bit related to this question number 26 about naming an interesting fact about the planets. I think Mercury gives us plenty of interesting things here. First thing that I sort of remember, it's very dense. In fact, it has the most iron in the solar system. Number two, it has a curious magnetic field that sort of seems to defy the rapid spin and the active geology that we expect of a planet that has a magnetic field. Number three, it has a bunch of strange timing. And timing, of course, strange timing, I mean relative to things on Earth here. Because you have its orbit and rotation. And what we discussed about the orbit then is very fast, 88 days. Think about that, all the way around the sun once in 88 days. Nothing like our 365. And the rotation once around its own axis is very slow, 58 days, needing the Doppler effect to find it. And so that's, of course, where our Doppler effect came in. And so I'll just close then by just showing you one quick animation that has to do with Mercury's very fast 88-day orbit. But these are the three things I think would be interesting to know and remember about Mercury. And so one last time then on the orbit here, the reason why Mercury's orbit is so fast is if I go over here, then here's the sun, here's the Earth, and I turn on the velocity and sort of let the simulation go, you can see that at the direction of the Earth's orbit, that nice long red arrow is just about right to have the Earth make a nice orbit around the sun, and that's sort of our velocity there. So let me just reset that, turn the velocity back on. But of course, you know that Mercury is much closer to the sun than the Earth is. In fact, Mercury is something like this, right? Very, very close. I think it was 0.4 AU. So if I run it now, you see that, yeah, the Earth's velocity that we have just isn't going to do it, is it? So Mercury is very close like that. You'd have to turn the velocity on here and maybe extend it quite a bit, much faster than Earth. Let's see if I can even get it going this way. Yeah, well, look at that. Looks like my first guess sort of got it there. So you see, though, that the Mercury is going to have a much larger speed in order sort of to compensate for the fact that it's so much closer to the sun and the gravity of the sun is so much stronger. So let me just see what will happen. One last thing. This will be my last bit here. If I sort of stop it there and I'll clear it, suppose then I drag this all the way out to where we are, but I still leave this long arrow on there that's sort of for Mercury. What will happen to the Earth? Yeah, see, it's just too fast. It's too fast for the Earth. So we're just going to send us off into the lost reaches of the solar system and maybe even the galaxy too fast, but not for Mercury. And also just one last thing on that orbital time. Of course, if Mercury is very close like this and I turn up the velocity and get it very high like that, something like that, maybe to achieve the orbit, watch how many Earth days it takes all the way. Oop, not enough, right? Not enough. Let's see if I can find that again. Go a little faster now, something like that. Maybe I'll zoom back a little bit, get something a little faster like that. And there we go. And you see I go all the way around in. Watch the timer, watch the timer. Bang. Wow. Almost right. 81 Earth days. So it's 88 for Mercury. And I was just guessing here. But you can see as you get the faster speeds that are required to compensate for the stronger gravity, given that you're so close to the sun, you will go around the sun in a short amount of time. In this case, 81 Earth days, not the 365 that we're used to. So there we go. There's Mercury for you.